Attending this conference, definitely I would say to get a lot of insight who are already working in the industry. They are already here, a lot of trading firms. I am into finance, so I met a lot of people who are already in finance and they gave me a lot of insights.
All right. Hi, everyone. I'm Florent. I'm working at EngFlow. Me and my colleagues, we really like fast builds, and we like to help you doing that. And today I'm going to teach you one trick that allows you to reduce the binary bloat with thin archives. So if you look at the compilation model for C++ in general, you take some source files, you compile them into object files, you take those object files, you merge them into static archives, and when you take some object files and static archives, you link them into binaries. That's the basic model. Let's go dig into static archives, because a lot of people don't know much about them. So what's stored in a static archive? Well, you have a copy of object files with some metadata, and you also have a symbol index, which is a list of all the exported symbols from all the object files in there, which the linker used to make things go fast. Typically, the archiver program you're going to use is going to be AR, Linux, macOS, BSD, or lib on Windows. And I show you some command line, which is very simple, arqc, output and then inputs. That copies all the files in there. And then you can have another command called wrangled that you run on the archive, and that adds the index to make things go fast. So if you look at the build folder content for a few different projects, I took CMake and Clang, both built in debug mode on Linux. You have CMake, which is several hundreds of megabytes, and you have about 200 megabytes of objects, and about the same amount of archives in there. For Clang, you have a little bit over 20 gigabytes of objects and archive. And as I told you, well, archives contain a copy of all the objects. It feels a little bit wasteful. So why do we use static archives? Well, static archives are a solution to solve circular dependencies between interdependent object files, because sometimes the linker needs to go find a symbol and usually finds the symbol on the things after in the command line. But if you have circular dependencies, it doesn't really work, so you put things in archives. That's also a way that is way more convenient to link things. Putting one archive is better than hundreds of object files. It's good also for redistributing an archive, for example, to some clients, consumer, installing. But it's also a good way to waste disk space and disk I/O. Wait, what? So I'm going to teach you a way to reduce some of that binary bloat. That's called thin archives. It's been invented in 2008, so it's quite old now. And instead of copying the files in there, you just copy the name of the file, because the file is already on disk next to the static archive. So why do you need another copy of it? You still have in there the symbol index for linking, because the linker needs that instead of opening hundreds of files. That is a lot more efficient. And the linkers just use them the same way. It's totally transparent. You create a thin archive using a flag called --thin or -t with all the versions, and you use it the same way. But it's not good for redistribution because, well, it's just the name of the file and not the content of the file. So if you look at some numbers, you'll see that, for example, in the case of Clang, instead of having a big portion of the build folder disk space being used by archives, you have less than 0.5%, and you're saving 20 gigabytes there. So it's pretty good saving. So what's the catch? Are you impacting archiving times? Yes, positively, because you do less work. So that's good. And if you have a slow disk, it will be faster. Most of the time it doesn't matter because we have fast disk, but you never know. Is it impacting link time? No, as fast as ever. So the only thing that matters is if you try to redistribute views, it doesn't work, but then you can use some tools to convert them into regular archive, and then they will just work as before. You could talk also that they're a good way to merge archives together, but I don't have a lot of time, so I'm going to skip that. How to use that? Variables in CMake, for example. You add --fin into all of those, it will work globally. And that's a fine way. You have another way, more modern, with properties, static library options, --fin, and it will just work on all the libraries you want. If you want it everywhere, you'll need more work. It works on Linux since 2008, macOS and Windows if you have LLVM toolchains. And that's it. Thank you.